Hey YouTube, just an update. That's the EP Ever charge controller that I'm using on my system. I have updated a few things. I've manufactured this little box to keep it out of the weather. If I turn around, you should be able to see my main switch and go down to my rectifier. And a new feature, those big capacitors. If you have a look at them, they're about the size of a beer can. I put them in the line to reduce the rectified ripple. As I'm using this EP Ever solar charge controller, rectified AC can or does still contain what they call rectified ripple. To reduce that and bring it to an almost consistent flat line DC voltage, I fitted these ripple control capacitors. This is my latest purchase, Must 3000 watt low frequency inverter. The grid in and the grid out at the top. The white wire is the grid out. The black wire is the grid in. As you can see, it's all shut down, it's turned off. I don't need the grid. The grid facility is there as a charger in case for some reason I decide that I want the grid or my green energy doesn't work. That is the 12, or in my case 24 volt input, and there is my mains AC 240 volt switchboard with dual circuit breakers for each circuit. Okay, this Must unit, it is a charger slash inverter. It can run off the grid and batteries or batteries. At the moment I've got it in battery feature. You can see the load is bouncing around between 0 and 2%. It's only running the farm electric fence energizer. And the battery you can see here is fully charged, and you can see just coming from the batteries through the inverter, and my load is less than 25%. The electric fence unit doesn't use much electricity at all, but it uses in pulses, as you can see there, with the current load going up and down, up and down. It is normally, it's not normally, it is 30 degrees here in this battery box. As you can see, the input is 0, and we have currently 27.2 volts in the battery and 100% charged. And that's the power that this is capable of making, and is sending out to electric fence unit only at the moment at 230 volts at 50 Hertz. And again, my load is 0. Now it gets warm in here. I had a tube wired up to a fan to a thermostat on the side of the inverter. So the hottest part, I used a laser thermometer. I found the hottest part of the inverter and put that thermostat there. When that reaches the correct temperature, it will close the circuit and turn the fan on. And down there are my two air inlet tubes.